All right, now for number 2, I'll just leave that there so you can see it on the recording, all the work. Now, number 2, you have 4 different numbers. Please recognize that these are just numbers. That's all they are. And we need to get what they are approximately, and then we can put them in order, okay? So let's start with tangent of pi. I'm going to start with tangent of pi. Okay, you need your unit circle. And then I'm going to go to where pi is, which is right here, pi. And that's the point -1, 0. So you should remember that tangent is sine of pi over cosine of pi. And that's -1, I'm sorry, sine is 0. That's the y coordinate. Remember, sine is the y coordinate of that point that you arrive at on your unit circle. And cosine is the x coordinate. So it's 0 over -1, which is just 0. So tangent of pi is equal to 0. Any questions? Okay. All right. Now for sine of 3 and cosine of 3. So when I look at my unit circle here, I need to travel around first 3 units, walk 3 miles, whatever you want to, however you want to say it. Now, if I go all the way to here, let me use a different color. If I go all the way to here, that's 3.14 approximately, which is pi. I don't want to go that full distance. We need to stop just short. So we did this one last week. This is where I want to stop. Let me back it up. I don't want that whole circle there. So 3 is about right here. Here is 3.14. Is that okay? Everybody cool with that? Any questions about how we get to that point? All right. So then you have to estimate your coordinates. Did anybody get estimates? What is the x coordinate here? Everybody said -0.99. Good job. Okay, it's going to be almost -1, right? The x coordinate goes almost all the way to the edge there. Even though it looks like it's directly over, it's just my circle stinks. I didn't write a good circle. So it's going to stop just short of -1, so about -0.9, 0.95, -0.99. And the y coordinate, I would go up, I don't know, say about 0.2. So then my sine of 3 is going to be the y coordinate, which is -0.9, I'm sorry, which is 0.2. And cosine of 3 is approximately, remember, use the squiggles, the approximately sign. This is -0.99. So this is approximately -0.99, and this is approximately 0.2. So all that leaves is pi over 3, and it's negative. Now, I don't really need the unit circle to do this. I don't know if you guys remember last week, but when we set up the unit circle, we can calculate this. This is approximately 3.14 negative divided by 3. Okay. Now you can divide that. We can do a little bit of work here. 3 goes into 3 once. That's 0. 3 will not go into 1. I got to bring down the 4 also. Oh, let me do that slowly. Well, no, this is how you do it. So 3 goes into 14 4 times. And I do have a remainder, but so what? I just want an approximation. This is going to be about -1.4. Is that okay? 1.04. I misspoke there. -1.04. Any questions on how we came up with that? Did anyone do that a different way or think about that differently? if you have really good number sense, and some of you out there really do, you could think, okay, 3.14 is a little bit bigger than 3. When I divide by 3, I'm going to get something a little bit bigger than 1, which is what happens. And then you just slap that negative on the front and you got it, okay? Ooh, I kind of forgot my negative here. Okay, negative 1.04. Okay, all right, so now that we have all that, we can put these in order. What is the smallest number? Put it in the chat. Which one is the smallest? The least. You guys check out on me? All right, you got a couple different ideas here. Yes, yes, okay. It's the negative pi over 3, that's right. Negative 1.04 is the most negative number. Think about the number line. So negative pi over 3 is the smallest. And then, what's next? Sine of 3, because that's negative, is negative 0.99. And then, what's after that? Little confusion. All right, tan of pi, because 0. And then cosine, because that's positive, okay? So think about your number line, okay? Here's 0, that's my tan of pi. Here's negative 1, okay? Negative 0.999 is going to be right before negative 1, and negative 1.04 is going to be right after it. So you have to like remember it's opposite, you know, when you're going with the negatives. Oh, sine of 3 is negative 0.99. It is not negative 0.99. I mixed those up. How come nobody said something sooner? I wrote it down here correctly and then wrote it up here incorrectly. This should be 0.2 and this should be negative 0.99. Sorry. See, here I wrote it right and then somehow screwed it up. So yeah, these should be opposite here. So those of you that had cosine and sine, that was right. Okay, questions? Thank you, Javion. Okay, let's do one more of those, actually. I might even do a couple, because this is a final exam type question. I pulled it right from a final. You have to be able to do these. Here's a good one. All right. So, what are my directions here? Arrange in order, smallest to largest. Sorry, the writing paused on me. Okay. Let's try this. Okay. Sine of 5, cosine of 5, log base 5 of 6, and tangent of 2 pi. Okay. So let me give you guys a minute to think about those. You can figure out at least 3 out of 4 of those. We've been doing them right along. Okay, so on our unit circle, remember the first stop is pi over 2, then pi, then 3 pi over 2, and then 2 pi. And then I put the decimal approximations there. So let's walk 5 units. So I'm going to start at the beginning. And here's 1.57 miles, not enough. 3.14 miles, still not enough. 4.71, still not quite there. And 5 is going to be about right here. That's the point on the unit circle you would get to. Okay? Now, let me carefully get these X and Y coordinates. So X, would you guys say is about 0.4, maybe a little bit before half? And Y is about negative 0.9. We'll say that, or negative 0.8, either one of those. So remember, sine of 5 is the Y coordinate. We double check, make sure I picked the right one, negative 0.9. And cosine of 5 is the X coordinate, squiggles, is approximately 0.4. Okay. Now here's where it's smart of you to show all your work here. Let's say you do this and you write down the correct point. But then when you go to write them down, you switch them like I just did in the last problem. Or, you know, like if I had looked at this as someone's work, I would have thought, oh, they knew it and then they made a mistake up top. Like that's going to get you most of your points. If you just write down decimals, do this in your head, and you screw it up, it's no credit. Okay. So just be aware of that. All right. Tangent of 2 pi. These are all the trig ones. Okay. 2 pi is here, right? And that's going to be sine of 2 pi over cosine of 2 pi. And that point is 1, 0. So sine is 0 over cosine is 1, and you get 0. So tangent 2 pi is 0. Any questions about those? So the one that's a little bit rogue here is this log. So let's look at log base 5 of 6. The question is 5 to what power is going to equal 6? And the quick answer is, I don't know. Not a whole number, right? That power can't be 1. 5 to the first is 5, and 5 squared is 25. So it actually has to be a decimal, which is going to be approximately, I don't know, 1.1. You guys see that? So you can also get thrown a log that you have to approximate the power on. Any questions on how we figured that out? So again, I look at 5 to the first and 5 squared, and I see that 6 is going to come right in after 5. So in terms of powers, just to be really clear here, that power has to be really close to 1, right? Because 6 is really close to 5. Okay. All right. So then putting this in order, don't forget the last part. I look at what I'm working with. I have a negative 0.9, a positive 0.4, a 0, and then a positive 1.1. So clearly the negative comes first. So sine of 5 is the smallest. Now, 0 is the divide, like, you know, comes between the positives and the negatives. So that's next, tangent 2 pi. And then we have cosine of 5. And then the biggest one is actually log base 5 of 6. Any questions? All right, tell me how you guys are feeling about these with your signals. Either give me a thumbs up, like, yeah, this is cool, got it, or And oh no, like what the heck? Let me see. What do you guys, how are you feeling about this? Hello? I don't see anybody. All right, I got 1, 2, 3, 4, 5, 6 thumbs up. Okay, one person not sure. A couple people not sure. All right, let's do one more and then I'm going to introduce the new topic today. We'll only do 11.4 and then tomorrow will be 11.5. This one's a little bit tougher actually, so it'll be good for you to see it. So arrange in order from smallest to largest. So we have sine of 6.2, cosine of 6.2, negative square root of 2, and tangent of 3 pi. And I'm tell you what, I'm going to assign stuff to people here. Trying to get you guys involved. So for this part, I'm going to go to Christy. Not yet, though. Don't tell me yet. For this, how about Braxton? I want to hear from you today. And for this part, let's go with Nija. Okay, so you guys think about this, try to get the answer, and I'll give you a minute, and then just so the people that you guys aren't feeling too much on the spot, go ahead and think about it first, okay? Okay, Christy, are you ready?
No.
No? Did you say no? All right. When you say no, do you mean you haven't finished the whole problem yet? Or you're still not sure about the sign part? It's not showing you what I'm drawing yet. Christy, are you there? All right, I'm not sure what's going on there, but would somebody like to tell us where to go to get to 6.2? How about Mason? What do you think, Mason? Why it's not updated yet? Where's my circle? I'm gonna stop sharing for a minute and then reshare because.
Wait, you want me to arrange them?
Oh, it's not sharing. For some reason, my screen sharing is paused. Why? What did I do? That's weird. Surely I did not choose that. There we go. I do that circle like 3 times and it just wouldn't show up. Okay, so sorry. Yeah, Mason. How do you get the 6.2 on your unit circle? Where would I go?
We gotta find it and then wait, hold on.
Yeah, how do I find it? I'm starting here.
You go counterclockwise, right?
Yes. All right, so you got to tell me when to stop. Oops, I went off my circle. Sorry. Still
it's all
going.
kind of merged and hard to see.
Okay, all right, so let's undo that. All right. I'll use the highlighter. Maybe the highlighter will be better. Okay, ready?
Would it be there?
Okay, so let's analyze that. Okay. You got to know your points. This is pi over 2, which is about how much?
1.57.
1.57. You have to know that. Memorize. Okay. If I keep going, I get to this point.
Which is 3.14.
Yes, good. And then what about this one, Mason?
Four, 3 pi over 2. I knew that, but
4.71.
Yes, good. And then when I get all the way back here, this is 2 pi, which is how much?
6.28.
There you go. Okay, so do you see how close we have to get to that? So to get the whole distance, this
yeah,
is,
just be right before it.
yeah, I'm gonna stop like right before. And actually this highlighter kind of fails to really show it, but you're gonna stop just before 6.28. Maybe I'll use the purple, I don't know. Everybody see that? So 6.2 is gonna happen right before 6.28. Okay, way to stick that out, Mason. All right, now, do you want to try to give me an estimate for these points? What do you think X and Y are here? Now remember, this point above it is 1, 0. You didn't quite make it there.
Oh, she put it in the chats.
Madison put it in the chat, yes. So 0.99, so for the X coordinate, you make it all the way almost to 1. But for the Y, you're just a little bit less than 0. So maybe about negative 0.1, or I would even say negative 0.01. I mean, it's right below the x-axis, okay? So if you look at Y to get to this Y coordinate, you're like just below there and just before the 1. Any questions on how we get those coordinates? Because that is the key to all of this. Like, that's the thing you have to be able to do. You have to be able to estimate those coordinates. Then once you have them, we have the information we need. Sine of 6.2 is just this Y coordinate, it's about negative 0.01. And cosine of 6.2 is this coordinate. It's about 0.99. Okay. All right, how about Braxton? Are you ready for negative square root of 2? What did you say that was approximately?
I got negative 1.4.
Yeah, okay. So that's just square root of 2 is, again, going to be a number between square root of 1 and square root of 4. We know that that's exactly 1 and this is exactly 2. So this is going to be a little bit closer to 1, so probably 1.4. And it's negative. All right. Okay, Nija, did you get tangent of 3 pi?
Yep. That turns into sine of 3 pi over cosine of 3 pi. And so the point on the unit circle is -1 and 0. So that turns into 0 over -1, and that equals 0.
That was a really nice answer. Thank you for that. Very thorough. You were like the teacher. Okay, nice job. All right, nice job, everybody. And listen, this is really testing your number sense. It's testing your visual, like how good are you at finding things visually? And if it's also telling me how the homework's going. Okay, so if you're not sure about this, you need to come to office hours or come talk to me, okay? All right, so now let's put these in order. The most negative, I have 2 negative numbers to consider. That's this one and this one. And so negative 1.4 is more negative. Then I have sine of 6.2. And then I have 0, that's the middle, okay, neutral, neither negative nor positive. And then positive is cosine of 6.2. Okay. Oops. Yes, you're right. Tan of pi and tan of 3 pi are the same. All right, so how about this? Give me a thumbs up if you got this order correct without using a calculator or checking it. All right, 1, 2, 3, 4, 5. Okay, good. 6, nice. All right. Okay, so let's move on. We're going to do 11.4. We need to talk about angles, okay? So we're going to talk about radian measure of an angle. So everything we've talked about so far has been this distance on the edge of the circle, okay? Which is fine. But it does correspond. Let me draw a nice circle here. It's a little ovalish. Whatever. I can't waste time. I'm just gonna draw it. Okay, that was pretty good for drawing it. I hope you're all a little impressed there. That was pretty good. All right, now my axes will be off. Whatever. Okay, so here's my unit circle. Here's X and Y. Now, what I want to look at are the angles. Let's see. So if I put an angle on my unit circle, this is one side of the angle. Here's another side of the angle. And at this measure right here, we're going to just label as theta. So you guys see an angle is formed from 2 rays, which I'm not going to go into too much geometry definitions here, but you have 2 rays that when they meet together at a point, they make an angle, right? So in your standard geometry course, for example, an angle less than 90 degrees, what do we call that? Anybody remember? Acute, good. 90 degrees is a right angle, and bigger than 90 is obtuse, okay? But we actually can have angles bigger than 180, all right? So it gets a little wild on this unit circle thing. So here's a couple other terminology things you need to know. This distance from the center to here, this is your radius, okay? And this piece right here on the edge, this distance we label as S, okay? And this is called the arc length. So the distances we've been talking about is really, we've been measuring arc lengths, okay? So here's a definition. The radian measure of the angle is, it's the arc length over the radius. So this is for any circle, okay? So if I want to measure if I want to measure theta in terms of radians, so this angle, theta is the angle, okay? If I want it in radian measures, I would have to take that distance, like what we just talked about, and divide by the radius, okay? Now, everything we've been doing has been on the unit circle. What is special about our unit circle? You're like, nothing.
It has a radius of 1. Radius of 1.
Radius. Yes, beautiful. Was that Nija?
Yeah.
Yeah, good, good, good. So on the unit circle, nicely said. On the unit circle, the radius is 1. Okay, so that means that my radian, oh, not randian, radian measure of theta on the unit circle is that length over 1, which is why we've just been talking about that distance, okay? It's this distance. When I talk about walking the distance on the unit circle, that is the radian measure of that corresponding angle, okay? So, a couple other things to know. So for example, just to really drive this home here, if I go on this circle 1 mile, okay, that means that this angle here, theta equals 1 radian. Okay. Okay. There's another one. If I look at this angle, now I look at theta here. That's the distance on the unit circle. Again, I'm on the unit circle. I just want to make sure that's clear. I'll just put 1 point on here to make sure you know it's a unit circle. If I walk along this distance, that is the same measure as that angle, which is how much? This is pi radians, and this is what I call pi miles. Okay, the distance of the distance on the arc and the distance of the angle are the same on the unit circle. Okay, so this one is significant because what other angle are you guys aware of that looks like this one I just drew? What other angle in geometry have you seen before that is that measure?
80 degrees.
180 degrees, exactly. So from geometry, hopefully in high school you saw this at some point, an absolutely flat angle like this is 180 degrees. So now we have a potential conversion unit. This is what we're going to use as our way to convert from radians to degrees. So 180 degrees is equal to pi radians. Okay. If you take that 180 degree angle and you put it on your unit circle, it measures pi radians. Any questions on that? So I am going to run out of time today, but I will tell you one last thing before we end. there's two ways to look at this. Okay. If I look at this equivalence, 180 degrees is equal to pi radians. If we divide both sides by 180 degrees, 180 over 180 is 1 degree, is equal to pi radians over 180 degrees. Okay. Similarly, if I take this, go back to my original 180 degrees equals pi radians, and instead I divide both sides by pi radians, then that means that 1 radian is equal to 180 degrees over pi radians. So more specifically, 1 degree is pi over 180, and 1 radian is equal to 180 divided by pi. Okay, so I'm gonna have to look at the homework I assigned today. What we're gonna pick up tomorrow on is converting, going back and forth. And maybe I'll even have, you guys have workshop today, right? I might even have Omar do some examples with you at the beginning, because if it's on the worksheet, I want you to practice it. Okay. All right. I will let you go. You guys have a good day. I will see you tomorrow.